Okay, so we are starting Unit 2. Now listen, with Unit 2, the things that I still talk about will spiral back into Unit 1. So what we talk about at the very, very beginning here right now will definitely help you for your test next class. Okay, so just a reminder for the video, for people who are not here, those links to all the test review videos will be on the calendar that you're used to just going and finding it. Okay, so please use those. All right, need a volunteer to answer this question. You have probably an idea. You probably have no idea. But do I have a volunteer to tell me what they think a system of equations is? Any volunteers? Okay, so your team gets 100 points. So, Maddie, what do you think a system of equations is?
Like the sequence that you have to follow.
Okay. So the sequence that you have to follow for what?
So like PEMDAS, you know, that's
Okay. So you're relating it to something like PEMDAS. Okay.
I think it's like a set of equations that are related in some way, like they share a point.
Okay. Charlie?
I was just basically going to say what you said.
Same thing. So equations related in some way. Nanika said specifically like a point. Okay.
I think it'd be like when multiple equations are by each other.
Okay.
Multiplied or any of the PEMDAS together.
Okay. So he's kind of mixing these two together. Okay. Parker?
My name's Joseph.
Oh, my bad.
Two more,
Your last name is Parker. Your first name's Joseph. Okay, go ahead.
two more equations that are used to solve for a variable.
Okay, so solving for a variable. So two or more equations, and you're solving for a variable. Okay, from all that, I'm going to show you what a systems of equations is visually here in just a bit, but first we're going to look at what it is verbally. So with all that, I want you to think of what a systems of equations is from this. Okay, remember, we need notebook sheets of paper in our binders as well, because there are days, many days, that I will not have everything that I'm going to give you in notes form, but also in notebook paper form. Okay. So a system of equations is exactly what it is. It's a system, meaning two or more equations. Okay? We're going to do a lot of algebra in this unit for sure. Okay? Recalling a lot of skills that we learned from Algebra 1. When you first encounter a system of equations, it's in equations because it's two or more equations, just like it was mentioned. You'll be solving for problems. So yes, we're going to solve for variables. We're going to solve for certain types of variables, whether they're 2, 3, 4, 5 equations, okay? But they will always be, in this unit, they're going to be systems of linear equations. You'll see a bunch of y equals mx plus b's. You with me? That's a line. Is this a line? That is a line. ax plus by is equal to c is another way of seeing a line. You with me? This is the y-intercept form, or the slope-intercept form. And this one, does anyone know what that one is? Standard form. So standard form. Now, let's talk a little bit. To help you with your piecewise function pieces in your test next class, some people have come in for tutoring have been struggling with the following. Check this out. If I have a graph that looks like this, let's say at -3, -2, it's open and it looks like a line, just like that. And from the graph, I can do like a rise over run, and I see a slope of 2. Let me remind you how to find where will it cross the y-axis without having to count. You don't have time to count. And sometimes it's so small and the numbers are so big that it's hard to count and be accurate. Let's do the math behind it. If I know that this point would have existed at -3, -2, what I can do is I can use this equation to help me find where would it actually cross the y-axis, aka the y-intercept. I know my slope from rise over run is 2. And now what I'm going to plug in for x is this x value right here. What I'm going to plug in for y is this y value right here. It's any x or any y value that would lie on that point or that line that you can use to solve for b. So I'll have a -6 is equal to a -2. You're adding b, and again, your goal is to find this so that you could say, where would it have crossed the y-axis? Anyone, what do I do to solve for b? Add 6 to the other side. So b is equal to -2 plus 6 is a +4. So if it were to keep going, this would go at +4. Go with me? So now that you have your b term as being 4, you know your slope was 2. I can build y equals 2x plus 4, and this piece could be written as your piecewise function for this particular one. It's a little bit of warming up with linear functions and lines, but at the same time reinforcing how do they work with what we were just using with piecewise functions. So -3, and to the left, you would add a domain that looks like this. X's that are less than -3. Are we good? So 2x plus 4 would be that line. Any questions from what we just did? Okay. So, a little bit of review of something else. I'm trying to help build you in all ways. Let's say 2x, let's say -2x minus 5y is equal to 10. What's the slope? 3, 2, 1. So some people said -2. What other answers were out there? Positive what? 2? So let me tell you, to find the slope, you're used to finding first this form. And then whatever number this is, right here in front of the x, that's your slope. If we did that, what would you do to this equation, guys, to get y by itself? Anyone, just say it out loud. Add 2x. -5y is equal to 2x plus 10. Notice that I'm trying to keep it as much into y equals mx plus b form so that I wrote the x first. I didn't write 10 plus 2x. Okay? Anyone? You don't have to raise your hand. What would I do next? Divide by -5. So dividing by -5, I want you to write it as close to this form as much as you can, this unit. So this would be y is equal to a -2/5 x, what? Minus 2. Perfect. Because a +10 divided by a -5 is a -2. Bless you. Now, the slope you can see is -2/5. A lot of the characteristics that I'm trying to teach you and show you are not just to do well in this unit, but it's more so to identify and be able to read faster when you're doing problems on PSAT, which is coming up in about 5-6 weeks. SAT, ACT, okay? The way they word these problems and the way that they're given with linear functions, I would say 99 out of 100 times they're given to you in standard form. And they ask questions like, what is the slope? What is the perpendicular slope? So on and so forth. What would the equation in this line be with this slope? You with me? So the fast way to identify in this form, slope is -a over b. So a was -2. b is -5. So if I put a -a over b, you can see that two negatives make a positive, but this third one would make it back into a negative, and the slope real quickly, without even doing any Like you would do this in your head pretty much. I'm just showing you for demonstration purposes. So a fast way to identify a slope is negative a over b. I hope you use that trick, okay? Not just, oh, that was cool. No, 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 it works a lot, okay? As far as making you fast. And today's problems, I want to build your speed. Not just build your know-how, but build your speed and see how well you can make the decision of what is better, what is faster, and why. Okay? Here we go. There are 3 sets of systems of equations in front of you. You with me? There are 3 different types of answers that you will have with systems of equations. Okay, and we're doing this all Unit 2. Systems of linear equations and inequalities. Those less than or equal to signs. Okay? Now, let's think about this. Now I know the answer is here. I have one solution. It's right here. I have no solutions. And then I have infinite solutions. Someone give me another word, a synonym, for solutions from what I just highlighted and what you see. An answer? A variable? Any other? Say again? An intersection? So we have an answer, a point, and an intersection. This is why I knew that this period was going to be awesome to use this video for, because all 3 are correct. A solution is an answer point or intersection. But there's 2 other types of solutions that are up here that are not necessarily a point or an intersection. It will be this dependent coinciding lines. Coinciding means they're exactly the same. They lie right on top of each other. No little piece of that line is off. All the pieces of both lines are on top of each other. So guys, right here, there are 2 lines, and someone last period was able to give me an example. I'm looking forward to that again in this class, of how you can identify 2 lines that lie right on top of each other without giving me the same equation. Okay? For instance, or actually, let's move on to parallel lines. No solution. Okay, so it's none of these. It's no solution, infinitely, or just 1. So write this down in your notes. 1 answer, infinite answers, or no answers. So no solution. Now I'm going to help you identify, because you're going to be able to use shortcuts if you learn these that I show you, that you don't have to do all this work sometimes. You can go straight to the answer because of the shortcuts you've learned. Here we go. Let's look at this first one. And I want you to tell me on this first one, what's the same and what's different. What do you see that's the same?
That one point that's intersect.
Okay, so the same intersection. And we're going to say it's the point. One point and only 1 point. The same x and the same y. What else do you see the same? There's nothing. You're right, there's nothing. Alright, what's different? Go ahead. Different slopes. So different slopes, for sure. What else is different? Anyone? Y-intercepts? Otherwise that B term, right?
X-intercepts.
X-intercepts. So that's not with a letter, but X-intercepts. What else? Okay, so if the slopes are different, let me see what Joseph was talking about when it comes to different slopes. What does that mean? You tell me, Joseph. What are you trying to say?
Their angle different.
So what numbers could you give it?
What
that's different. What's another way that it could be different?
Well, I was gonna say, is that they're like opposite reciprocals, so if one's like 2, the other one's negative.
Okay, so we have opposite or negative reciprocals. And if you don't know that already, those meet at a 90-degree angle, right? 90 degree, they're perpendicular to one another. Are these opposite reciprocals, anyone? No, but they're different, right? They're both correct right now. Does one have to be positive and the other one have to be negative? They don't. I could have something that has a slope of 2 and something that has a slope of 10. The biggest word that I want to touch on is they're different. They're different slopes, and it guarantees, if they're different, that you will only have one answer. So that you can figure out what you're looking for, it guarantees that you will have only one answer. You with me? These are the shortcuts that I'm trying to help you that are above just learning these definitions and words and stuff. Are we good? Okay. What are the same with coinciding lines? Go ahead.
Slope and
The slope, the
y-intercept.
y-intercept, what else? X-intercept? Everything. Everything is the same. The points, everything. You with me? This one's a little bit more higher level to understand though when I ask you for those examples here in just a bit. Okay? And then parallel lines. Anyone, what are the same?
Slope.
The slope, okay, so we'll have the same in different columns. So, slopes. Anyone else? For same, still the same. You're right, that's it. There's nothing else the same. Alright, so let's go different. We're talking about the third one now. We're talking about parallel lines. The only things that are the same right now are the slopes. It could be 2 and 2. It could be 5 and 5. It could be negative 10 and negative 10. They're parallel lines. They'll never, ever, ever cross. You with me? They'll never touch. So you'll never have one answer. You'll always have no solutions. Think of them as railroad tracks. That's a good analogy people like to see. You hope to never see those railroad tracks intersecting because that's a derailment of that train. Yes?
They have different y-intercepts.
Yes, different y-intercepts and x-intercepts, right? Anything else? That's it. Those are good things. If you can recognize these, everything is easy. Everything in this entire unit is easy. Okay? Yes?
This is like not the same and different, but parallel lines are a function.
Oh, look at you. Ho, ho. So she just said, are parallel lines a function? Together they're not.
They don't pass the.
Because they don't pass the vertical line test. But here's what I'll say.
Oh, no, they're
Nice.
different.
So a vertical line test, right? Because they're hitting at both places. We're not working with functions to see if they pass vertical line test. We're working with systems of equations to see when do they intersect, when do they not intersect, or when do they always intersect. You with me?
So we're not talking about functions.
No, we're not. So kind of disconnect yourself from that. Now listen, each line by itself is a function. It passes the vertical line test. But when we have a system, we're not following those rules. No one has said that out of all my classes so far. Nice catch. All right, let's go to, come on. Sometimes the computer's slow. All right, now listen. We're going to learn how to solve systems of equations 4 different ways today. Okay? Which way can you pick? Well, here's the thing. I think you need to learn all 4. But let me explain why. Please don't get comfortable with just one way to do it, and I'm just going to do it. That's my favorite way. I love it so much. I'll never do anything but just that way. Because there's calculator and non-calculator parts to SATs, to PSATs. and you will lose a lot of information if you put all your eggs in one basket. So get good at all the methods. Okay? Let me show you what we're looking at today. We're looking at graphing. We're looking at substitution. These are all methods. We're looking at elimination. This one's the one that I feel people should get really, really good at. Because if you can do elimination, you can do any of these like that, whether it's calculator or non-calculator. And then the last thing, I'm going to teach you some inspired tricks. Okay, obviously you can use these on the calculator portion, but I would say elimination, if I were to say is my favorite, if I were to have a favorite, I'd say elimination is my favorite. Okay, substitution. Should we get good at substitution? The answer is yes, we should. I will ask you later why. You don't know yet, but I will ask you later why should we get good at substitution. But I'll tell you right now, substitution you'll probably use 1 out of 10 times. For every 10 problems that you experience, you might use it once. Okay? But still get good at it. Alright. So follow me very closely. We're going to go with the calculator. Okay? And I'll let it keep recording because I want you to see what I'm doing. So right now I'm going to sign in. So that you can see my calculator up on the board. And now let me pull it up. So follow me real closely, please. First of all, home to menu C. Okay, okay, just like always. Okay? From here, we are going to grab a new document. So press 1. And if you fall behind, just put your calculator down and sit there, look pretty, and watch, please. And then you can look at it later. And then press 1 again for adding a calculator page. In good habit, we will do Control Doc, and we're going to add, by pressing number 2, a graphing page. I'll tell you right now, graphs are cool. They're very beneficial. I, for one, don't necessarily use graphs. There's other things that I use that will find things quickly, and I will show you today here in just a bit. But we're going to start off with these equations that we just had, okay? We're going to graph them. Okay, so let's go back a little bit to our Algebra 2. Or sorry, our Algebra 1 skills. So our Algebra 1 skills say, if I wanted to graph these, I need to get these in y equals mx plus b form first. Because this is what we're going to put into the graph. Okay? So, anyone, you don't have to raise your hand. For the first equation, I'm going to get y by itself. Everyone, what do I do first on that equation? Add 3x. Here we go. So, make sure you do awesome work just like you did in Algebra 1 of showing all your steps. And now I'm going to divide by 2. When I divide by 2, I hope that you don't end up writing it like this. It's equal, it's equivalent, it's correct. But I want you to write it in mx plus b form. I want 2 terms to be listed. So broken up, this would be 3/2 x, anyone, plus what? Plus 4. Because 8 divided by 2. So this is my equation, but this is what I'm putting into the calculator. You with me? Alright, so let's solve for y on this other one. Let's get y by itself. Everyone, what do I do first? We can, but let's get to it in just a bit. Hold up just a bit, okay? I'm going to move this x over, right? So I have 2y is equal to negative x minus 8. Go with me? And now I'm going to divide by 2. So y is equal to a negative 1/2. Help me out. What? Minus 4. Again, I'm only putting this part into the calculator. Are we good? Alright, here we go. Follow me closely, please. in the calculator, you should see f1 of x. If you don't, look at this. I can press escape. It makes it go away. If you don't see it, press tab. Tab is this button at the far left, upper left. Now you see f of x. And we're going to put, follow me, control divide, 3 over 2x plus 4. And press enter. There's your first function. There's your first graph, your first line. Now, I'm ready to input my second function. Follow me closely. Press tab again so that you can find f of 2. And we're going to put in the other equation. The other equation that we're going to put in is control divide. Please press this negative button below the number 3. Don't press the subtracting key. And it's negative 1 over 2x minus 4. How many answers do you see? One. One answer, one solution. 1 point, one intersection. All those things that we mentioned. Now let's find out what are the x and y coordinates. Or what is the x and y coordinate at that point? Follow me closely. Here we go. I'm going to press menu. If I fall behind, just sit there, look pretty, just watch. Menu 6. Which one of these do you think I'm going to pick? 4, the intersection. You can scroll down to it or just click the number 4. And look at this. This will even prompt you with instructions. What is your lower bound? At the bottom left, it says, what is your lower bound? I'm going to soft mouse my cursor all the way somewhere to the left of that intersection. Anywhere. And I'm going to press the D-pad. And yeah, like if you press into it, whoops. Let me try this again. Menu 6, 4. And I'm going to press the D-pad something to the left. Now it will ask you, what is the upper bound? And if I soft mouse scroll to the right, it will appear, and there's my answer. My answer is negative 4, negative 2. Okay? Let me show you what this means so that you understand what we're doing. Negative 4, negative 2 is my answer. I would prefer that you write it like this. This is the point of intersection. If you wanted to do that, that's cool, but it might be a little bit overkill, but I'm okay with that. You could also write your answer like this. To me, I prefer this one, and you'll understand why. Okay, that's my answer. Either one is correct, though. Now, what's awesome, I mean absolutely awesome about this unit is that I can know what I'm going to get on a quiz before I turn it in. I can know what I'm going to get on a test before I turn it in because I can check all of my answers. Okay? Watch. If I put in negative 4 here, and if I put a negative 2 here, and I solve all this, I will get 8.
How do you know that it's negative 4, negative 2 from those equations if you didn't have the calculator?
So we're going to get to that. We're going to get to that if you didn't have the calculator, okay? But it will check out as far as giving me 8. If I plugged in negative 4 into here, and if I plugged in negative 2 into here, I would get a negative 8. Because negative 4 minus another 4 is negative 8. Here's the thing. Your answer, whatever it is, must work for both of the equations. Sometimes you might make a mistake where the answer only works for one, but it doesn't for the other. You didn't get the answer. You with me? Alright, so this is how you do it with a graph. We're going to get through all 3 before we go to lunch. And then I'll show you the trick with the calculator. Okay, here we go. So my answer right now is negative 4, negative 2. We solved it by graphing. Here we go. Let's do substitution. Now look, substitution is just like it sounds. Whether I'm on a football team, baseball team, subbing in for the pitcher, or third base, or if I'm on a volleyball team, subbing in and out, as far as rotations go, I'm looking at doing the same with these two functions. So my goal is to get one variable all by itself from any one of these equations. Which equation looks like it's the easiest and the fastest that I can get one variable by itself? The second one. Let's get x by itself. So the second one I can say is negative 2y minus 8. I just got x by itself. And it's this right here. You with me? Now what I'm going to do, just like I said, I'm going to sub in from this equation what x is equivalent to, but into the other equation. Okay? Don't sub in back into the same equation, because you've done nothing. Okay? You're just going to get back to the same original equation. You have to do it to the other equation. So sub in into the other equation. So here we go, let's build it. We have negative 3 parentheses plus 2y is equal to 8. And we are subbing in right here. So negative 2y minus 8 is now in place where x is being subbed in. Now I have this. Can someone tell me, this is the question that you should ask yourself all the time, why does that work? Why are we wanting to do that? Anyone? What's the answer to why did I end up doing this? Perfect. It's hard to solve it if there's two variables. But if we get everything in the same language or in the same variable notation, we can solve it very quickly. Okay? So here we go. We're going to distribute this. Negative 3 times negative 2, 6y. Negative 3 and up negative 8, positive 24. And we still have the rest of this. And now we're going to combine like terms. How many y's do you see? 8. And if I subtract the 24 over, 8 minus 24, anyone? Negative 16. And if I divide by 8, look at this. It's the same y that the calculator gave me by graphing. Now, to get the x, I'm going to take this y that I solved by hand, and I'm going to plug it into any one of the equations. My hope is that you don't plug it into the one that you came up with. Why? You might have made a mistake. And if you did, you're about to make another mistake in hopes of trying to find x. So
Why can't we plug it in?
So here's the thing. You can, but if you made a mistake when trying to get x by itself, you're just going to make another mistake because you're using a wrong equation. So that's what I always suggest, just to help people out as far as the headaches and whatnot, is try to plug what you got in one of the original equations. I would probably use this one right here. So here we go. We have x plus 2 parentheses is equal to negative 8. And if I plugged in my negative 2 for y, I get x minus 4 is negative 8. And if I add 4, x is equal to negative 4. Right here. I just showed you by substitution with no calculator what the calculator showed you by graphing. Questions? Alright, so I will show you the other form when we get back. So I will let you go to lunch about 2 minutes early. Please be back 2 minutes early.